All right, so I asked your group to roll a 12-sided die. And I'm going to go around, and if you guys, just one person at your group, just give me your group's number. Table 1. It was 6, right? Yeah, okay. So you guys are going to make a dot plot out of the 8 numbers so we got from our table groups. Table 2. Thank you. Table 3. Table 4. Table 5. I wonder if you get something lucky if you get 12. Good jackpot. Table 6. Table 7. And table 8. Great. Okay, excellent job. All right, so what I need you guys to do in your group is to put those numbers into L1 in the calculator and run one variable stats and put all of the things in from the calculator. But shape, I'm going to go with uniform. Does that make sense to everybody? Okay. I guess it's going to be 4.000, huh? I started writing too soon. No, 3.9799, I guess. Did you guys get the same thing as me? Okay, just checking. Okay, any questions about what we did? Did we all get the same thing? Are we solid on one variable steps? Yes. Okay. All right. So what we're going to do now is we're going to see what happens when you transform things. So you guys remember Math 1, Math 2, Math 3, we spent a lot of time on transformations. Let's talk about the different ones in math class. So shift up, shift down, shift left, shift right, reflection over the x-axis if it was negative. And then there was, if there was a number in the front, it was like vertically stretched by a factor of, vertically compressed by a factor of. And if you had sine or cosine waves or conics in pre-calc, you would have horizontal stretch and compression also. Guess what? There's only like 2 steps. Okay, one of them is adding. Okay, so what I want you guys to do is you're going to take each of these numbers and you're going to add 3. So these 2 ones are going to become 4s. Does that make sense? And this one's going to become 7, 8, 9, 11, 13, 15. Thank you so much. Okay, now I want you guys to put these numbers in L1 and run one variable stats. And you should, some things some magic should happen. I'm hoping. Okay. Oh, also shape. Uniform still. Okay. Any questions about how I got any of this data so far? Any of these stats? Anything? We're good? Okay, so now we're going to discover patterns. So I want you to take a look at the summary statistics for both sets. I have my original set and I have the set where I added 3 to each number. It's very specific that I'm adding or subtracting a constant. And I want you to see what changed and what didn't. Okay, so did the shape change? No. Did the mean change? Yes. And it went up 3. So what I'm telling you is you didn't need any of the dots. You didn't need to put any of that in one variable stat. You could have just taken your original mean and added 3. Lazy. Okay. Did the standard deviation change? No. And this is the biggest key and the most confusing piece to this whole lesson. So this is the, you know how every lesson's got its like thing? This is the thing for this lesson. What I want you to realize is when you add a constant, you're just shifting up and down the x-axis. You're not getting more spread out. I'm not getting +3 more spread out. They're staying the same spread out. They're just shifting back and forth. So that's what happens when you add and subtract. Okay, now let's look at this. Did these things all change in median and max? Yes. And did the IWR change? No. Okay, so pause. These two things are what kind of things? This is your chapter 1 knowledge right here. These two things are what kind of things? Spreads. Okay, and this, and this, we call those measures of location. So if we want to break this down into a rule, which I always do because I'm a math person before a stats person, so I just like, tell me the rule. So when you add or subtract a constant, the measures of location will change whatever that amount was, but the spreads will not change. And you just got to really imagine that shift. Okay, now we're going to multiply. Okay, everybody, so we are going to take our original data and multiply it by 2. So I'm going to come back up to this real quick. So do you guys see these ones? I'm going to go 1 times 2 is 2. And there were 2 dots there. You guys see what I'm doing? And then 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. What's happening to it? And I made the number line like this way on purpose. 8 times 2, 16, 20, 24. Okay, when you're ready, type these in the calculator and get your results. An intelligent interpretation of what happened to the data on the summary statistics. I'll take anything. Yep, all roughly double the, it's actually not roughly, it's all exactly double the amount of the original. Okay, so, but except for this guy, shape didn't change. So this is what I need you to know. Transformations in STEP don't change the shape. Shape doesn't change. Multiplying, dividing, adding, subtracting numbers, shape stays the same. Double, 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 double. So if we're gonna say a rule for this, we would say standards multiplying by a number affects spread and location. It affects everything, just the shape. We're gonna summarize these things into bullet points after this. Okay, now I need to tell you about the paper I just gave you. Did I tell you about Mr. Talbot and the arts and crafts? Okay, so this is gonna be our first bit of arts and crafts. We're not quite there yet. I'm gonna bring you scissors and glue. Okay, so I gave you the arts and crafts bits for the whole chapter, but we're only gonna put the first one in our notebook today. So just don't lose this paper, just put it somewhere because we will come back to it and put it in our notebook later. But this is the only guy you're gonna need today, this Fahrenheit Celsius. Here we go. Just put the rest of it in your folder notebook somewhere to keep for later. I try to print extra for just in case.
Almost every day.
Are you guys situated? Alrighty, guys, hi. Let's fill in our bullet points, please. Okay, so we have 3 rules basically that we're going to summarize based off of our rolling our dice data that we got this morning. And the first one is about shape. Okay, so our first bit. Shape is not affected by adding, subtracting, or multiplying, dividing a constant. Do you guys all know why I put adding slash subtracting and multiplying slash dividing? Because they're really just the same thing. It's like adding a negative is subtracting, and multiplying is the same thing as dividing, the reciprocal. We all get that those are really the same operations. Okay, so if it says dividing, don't get freaked out by that. You're just gonna look at the multiplication section. Okay, so that's shape. The next one is location. I promise you, the next time Mr. Talbot visits, I will have him WD-40, whatever table that is. I'm so sorry. Okay, now I feel like this is great. Like you're right now, you're like, okay, cool. Location is affected by both ad and subtracting. Okay, great, Mrs. Talbot. What's location again? Okay, let's put some examples of what locations, what I mean by statistics of location. So that when I say location, I mean things like the min, the max, the mean, median, Q1, Q3, like where a number is located is what I mean by location. Okay, and this is where I was saying, this is the part that if you're going to mess up, it's going to be right here. So people are like, they just kind of go through the motions and they don't think about the fact that when we added a number at the beginning, we added 3, they didn't get any farther apart from each other. It was just a shift. So it's only multiplying and dividing that affects spread. Let's talk about what types of things are spread. So like standard deviation, IQR, range. So you're never going to add a number to spread. Okay. Would you believe me if I told you that this is actually the end of the notes right there already? No. Okay, so I've given you an example and I've given you a formula. Before we start, I want to label this as a linear transformation. Can anyone tell me why that would be called a linear transformation? You got to search back into your math knowledge, not your stats knowledge. I heard it. Yeah, it's y equals mx plus b. Basically, there's a slope and a y-intercept. So, but what it's telling you to do is it's telling you to, and you guys know all this because you took math 1, you should plug something in for Celsius, multiply it by 9/5. Okay, so then your brain is like, oh, what did she say about multiplying? Okay, and then after that, add 32. Okay, and then what did she say about adding? Okay, so we are going to describe the distribution, which still means sucks. Every time you see this, describe a distribution, it still sucks, except when we do chapter 3, it's going to be socks the whole year, every single time. Okay, so the shape. Did it tell us the shape? Is there any mention of any kind of those shape words in this description? No. Okay, so what we say is the shape in Fahrenheit. Also, why is the little like degree? Is it because you read it like that? The shape in degrees Fahrenheit will be the same as the shape in degrees Celsius. Okay, all you have to do really is just say, I don't know what it is, but whatever it is, it would be the same in Celsius as it would be in Fahrenheit. Everybody good? Okay, next. Did it say anything about outliers in the description? No. Do you think that the outliers would change? No. And we could do the 1.5 times IQR rule to prove that if you wanted to, or you could just trust me that they would still be outliers. Because you're multiplying by 1. Okay, now center. Center, is that location or is it spread? Take a look at the things that we listed underneath location, right? Okay, so what you're going to do is you're going to say Fahrenheit equals 9/5, and then the average it said, which is the center, is 25 plus 32. Because it says location is affected by both adding, subtracting, and multiplying and dividing. So I need to multiply and add. Are you guys okay if I did this in my head? I didn't do it in my head. I mean, I stole it from last year's notebook. Okay, last thing. This is the thing. This is it right here. This is what's going to trip you up on the homework and on the test if you're not really careful. This is spread. Spread is affected only by multiplying. And the standard deviation is 3, so that's the spread. Do not add 32. That is what I'm saying. It doesn't get plus 32 more spread out. So you have to resist the urge to add 32 to spread. Just the multiplication only. Okay, now before you get all out of your spots there, I forgot to show you yesterday's joke, and I have a joke for today. By the way, every day that there's notes, I have a joke, so you should remind me. This was yesterday, so just quickly, yesterday, did we calculate and interpret percentiles? Did we calculate and analyze a cumulative relative frequency graph? And did we calculate and interpret z-scores? Yes. Okay. So here's yesterday's joke. Yesterday's homework was 1 through 19 odd. And this is 2 chickens. And it says love letter from a statistician. And he says you're 3 standard deviations above the norm. Okay, which means that you're like really, really, really above average. That would be a great love letter to send to someone. Especially like, I don't know, your stats teacher. Just, throwing that out there. Okay, here's today's. Did we understand the effect of adding or subtracting a constant to shape, outlier, center, and spread, and multiplying and dividing a constant by shape, outlier, center, and spread? And this joke says, and here's a chart that shows what you might see if you looked at a mountain range through a tennis racket. I didn't say the jokes were good. I just said I have them. The homework tonight is 21 to 31 odd, 33 through 40. I believe 33 through 38 is multiple choice, and then like there's review questions, I think are 39 and 40.